How come everybody is on this side? What is it? Okay, let's get started. This is not good. So before I get into the content for today, quick logistical thing. I don't see, I see very few or almost none of you have created a group yet on the Excel sheet on Blackboard. So I think you should try to create a group unless you want to do a solo project. But that is also fine, but you need to add your name there. So I would suggest trying to do that sooner. Yeah. So basically, try to create groups. The reason why I'm saying it should not be last minute thing is because this is the third lecture, and we only have 8 sessions. There, I think there are supposed to be 35 plus students. I don't think everybody's here, but that means there are going to be at least 17 or more teams. And it's even so 17 teams. So that's why the last 2 sessions have been, I think, are currently tagged for student presentations, which means that we have like 3 other lectures for really iterating over your project ideas and discussing that with me during the class. I mean, during like the second half of the class. So you should really make use of that time, unless you want to do a last minute project and it's not gonna, it doesn't work well if you do that. Okay. So really we should, so the plan is next 14, 21 and 28, the second half of the lectures. I know it's a question of like how much time it takes to do the demos of the main content, but the plan is you should have either working on the labs related to those sessions, and also discuss with your teammates, and also discuss with me if you need any clarifications and help. Okay. Really, that I think informally I've discussed the project in the first lecture, but briefly. But basically, this is an exploration of a tool. It doesn't have to be the deployment tools that we're seeing in the lectures. Okay. So many students try to correlate it. Oh, should we deploy an ML model like the way you're doing with web servers or serverless technologies and so on? No, deployment is just one aspect. There are many aspects in this whole area, right? But we can't cover all of them. So in the lecture session is really about let's understand the basic primitives and not really about any specific tool, although there are obviously some tools that we'll see. Whereas your projects, given a higher number of groups, is going to be very similar to some of the students who did the deep learning class. It's going to be to educate other teams, educate the rest of the audience on what tool you investigated, what's interesting about it, and what did you accomplish with it and stuff. Okay. So there are some example tools in that Excel sheet. So have a look at them. There are also some tools that were recently covered. So that's why they're like tools that you should not take. That's also in the Excel sheet. So just look at those tools and avoid it. But when I say tools, it could be visualization related, data annotation related, model management. I mean, many of the topics that we'll see in the slide deck, for example, management related, scheduling related, Docker stuff that we will do today. So it could be anything, but it has to have some relevance for influencing machine learning processes, the whole life cycle. You can take one slice of it and just see what's the exciting stuff that's going on there. Okay, this whole MLOps field is kind of new. I mean, it's definitely, maybe some incantation was there 10 years ago, but it's something that with a huge amount of availability of GPUs and people trained in data science, it's not just the statisticians and the data scientists who can build models, but we also need a huge set of people who can support those models in multiple ways, right? So anyway, that's the kind of context of the project, and I encourage you to kind of make use of the next 3 lectures to meet me during the lectures, during the second half of the lectures, basically. Okay. And so the report itself is due in 3 weeks, right? So definitely plan appropriately on 4 weeks, I guess. So let me get to today's goal. So we actually, by the way, these chapters are a little bit older notes. I'm not relying on them because they may have errors, things change, APIs change. So as I said in the first lecture, our source of material for understanding any tool is going to be the documentation of that tool. And today we'll try to do that with Docker instead of looking at my notes. So today's objective is, I'll look at the goals and then I'll go back to the slides. But first objective is to kind of understand what are containers, and where do they fit in the large scheme of things. What's the difference between a container and a virtual machine? And in terms of hands-on stuff, we'll create what is called a Docker image, and we'll probably skip uploading image to a remote location. Okay, just like code is uploaded here in GitHub, you can create something called an image. It's like a file, and you can upload to other locations. Where other people can take that file, the image file, and those are called registries in their in that field. Okay, so but we'll try to kind of at least cover 3 of these points. My objective is also to cover one of the tools, Git, today. Okay, Git and GitHub obviously today. So let me go back here. I won't recap the remaining next couple of slides, but basically we are still in the first bucket of things, and we're only looking at deploying a pre-trained model, as in the model that was snapshotted, somebody built it, whether on their laptop or some team already built it, and it may be going stale. I mean, it's not being retrained and so on with new data, but you have a model artifact, pickle file or something else, and you just want to serve it to an audience. Okay, that's the only use case that we're looking at in these lectures, but that's not the use case related to your project. Your project doesn't have to be concerned with this part at all, or any of these topics. Okay, so in this slide, I just made a minor change, which is I guess minor change is actually just tools of the trade rather than just tools. But we'll look at Git today. Okay, there are other tools, and hopefully I can cover some of them in other lectures, but Git is what we'll look at today. So in the second half, and in the first half, we look at the third point here, which is still in the first topic. So remember, if you want to think of it in terms of what did we see in the first lecture and second lecture, one end, web server, you do everything from operating system, although you're not concerned with operating system, you're concerned with your model being served, right? So operating system, security of the operating system, updating the operating system, like SSHing into it, setting up the software, everything else, and on top of that, writing your business logic. In this case, serving a machine model. On the other end of the spectrum, which is last lecture, we saw the serverless, a couple of serverless examples, which is using Google Cloud functions and AWS Lambda, which is you're not concerned with the rest of it. You basically outsource it to a vendor, and the vendor will say, okay, here's the environment. We'll take care of reliability, scaling, so extra things that you may have to handle, which we did not see, like scaling. What does scaling mean? Like having multiple models when the model serving time is slower, for example. So you outsource that to a vendor in the sense what you get is a managed service. Okay, so this managed service is a serverless technology. At least the ones we saw are proprietary, but you can also have non-proprietary functions as a service, or whatever serverless technologies. You can host it yourself as well. And so that's what we saw. Those are the two ends of the spectrum. You only care about the Python environment, you write the function, and the other side you do a lot of things. And in between is container technology. Okay, so if you want to think of it on that line. So the container technology is you still don't care about the operating system, but you can still control the Python environment, Python packages and non-Python packages, and you can box it up. And that box is what is shipped to different locations. It could be a Linux virtual machine, it could be a Windows physical machine, or it could be a laptop, whatever. And that box is just like that box is what has everything that your program, your function needs to kind of serve ML models. But there is an in-between glue code which helps understand the box and run it, and therefore when you run your code, it's very similar to, I don't know if you guys have worked with Java. So there's a Java virtual machine, and so you just write your code to work in the JVM, and doesn't matter where the JVM is actually running. Okay, so it's something like that. It's analogous to that. It's not exactly the same, obviously, but it's like that.
How is it different from a server?
How is so containers are like containers are just technically they're just processes. Like if you know on Windows, you can right click and see bunch of processes, not right click, but Windows Task Manager. You can see the process, or in Linux also you can see by just doing PS, right? Or actually, where is my cursor? So if I do, so top is a command specific to Windows, specific to, yeah, so this is, for example, my current processes that are running. But those are processes, like bunch of programs, basically. So containers are essentially processes. They're not servers themselves. They're not virtual machines themselves, but they're just processes. Okay, but we'll talk about some more detail, like how are they different from virtual machines and like full servers in the next few minutes. Yeah, but the short answer is they're just yet another program to be run on any system. Yeah. So let me go back to the thing. So here there's a bunch of names here in the brackets. So Docker is the technology that we'll see today. Podman is another technology by a company called Red Hat / IBM, but kind of they're interchangeable, and we'll not look at Podman today. Kubernetes is the name of a container management solution. So the moment you have, if you have a single container, sure, you can, it's one program, you can kind of nicely handle it yourself manually, perhaps. But if you have like 1,000 containers, which is kind of low for companies like Google and Microsoft, for example, you need a container management or container orchestration system. And Kubernetes is one such example. There are many solutions here. And obviously cloud providers, provide all sorts of, they will let you rent a web server or basically a virtual machine. They'll give you a managed service which is serverless. They'll also do the in between. Hey, we can run your containers, or hey, we can run your whatever images, right? Docker images. So AWS and Google have their own acronyms or services, managed services, which also deal with this. Okay, where you want a little bit more control, but you don't want to have full control of the actual virtual machine or actual server, right? Yeah. So ECS, I guess Elastic Compute Service. I don't know what ECS actually. I forgot. Elastic Container Service, perhaps. And GK means Google Kubernetes Engine, I guess. So there are acronyms like this. We'll explore it if we have time. I think it depends on the complexity. So we'll not discuss. So we still want to achieve the same thing. It's just that now instead of a server, we just want to have a box that we can ship to a server. And as long as the server has some program to run that box, which is the process, which is called a container from that box, which is called an image, then everything's good. Okay. So that the server, you don't have to log into the server and install, virtual environment, sorry, or update the packages so that there is no security issues and all that. Okay, it's the same trade-off. Yeah, this is done. Okay, so we'll get into a couple of figures after this slide, which further explain this. But in contrast to the previous two figures, as I said, in local development, we can create an image. Okay, this image is basically a name for a zip file, essentially. Okay, this is a zip file which has your program. If you need Python environment, it will have the Python environment. If you need any extra libraries which are non-Python specific, for example, OpenCV, right? It's a C or C++ based program with Python interface, obviously. But if you wanted OpenCV libraries and stuff, they can all be put into that box, and that box is an image here. And obviously, you can, once you have a box, you can run the thing, which is a container, which is a copy, or not a copy, but like a process, short-lived thing that you can run from that image. You can run it locally, but you can also copy that image anywhere else. As I said, it's just a file. You can, download the file on the other side, and you can run it anywhere. Okay, server 1, server 2, ECS, and all these managed services. So all you need to give them is a box, and they can run it for you. And obviously, some of them have more capabilities. They can manage. They can do management of these images or boxes, and they can run multiple copies. Or if a copy fails because of some internal error, like you didn't catch an error and it failed, they can monitor that and then restart another container, for example, and so on. Okay, so those are things that you can do with these managed services, as well as the Kubernetes software if you install it yourself. Okay, and you can do all this locally. Okay, you don't have to use the managed service providers, except for that cloud function. Even those you can actually have some software you can run locally and see that function as a service, a type of a serverless technology. But last time we just tried using cloud services. Okay. So let me just mention the tool names, and then we'll look at another slide. We'll actually get into the detail of this, this container business. So I think I mentioned these names before. If you want to run Kubernetes, which is an orchestration system for containers, then there's a software called Minikube, which is like a mini Kubernetes, which you can run on your laptop. It can work with the VirtualBox virtual machines that we spoke about in the previous couple of lectures. Okay. And you'll come across I mean, we'll see if we come across this, but yet another markup language, YAML, is just a text file, just like config file, .ini files, or .config, or anything which is like textual, which says, okay, this setting, this setting, this. So YAML files are like that. Okay, we'll see some of those files. Mostly today, in fact, for the demo, we'll kind of use this sudo docker some verb to kind of take some actions in our demo. The sudo part is only because Docker, by default, at least my installation doesn't have elevated privileges, and I want elevated privileges. But depending on your installation, you may not need the sudo part. Okay. Yeah, and the other names, let's ignore it for now, but they're just managed services. You can Google them later. Okay, so what we'll do is actually directly get to, okay, actually, before we get into the demo part, don't think this has anything major going on. Yeah, so there's some description of what containers are, but let me skip and directly look at some pictures. Okay. I'll just explain by the figures that are there in the notes rather than go through each of the detailed points. So in general, this is how your operating system, your computer, your laptop, for example, is, right? So there's a CPU, there's memory, there's a bunch of devices like the keyboard device, the mouse device, the webcam device, and so on. And there's this key thing called a kernel. I don't know if you've seen the blue screen of death on Windows. I don't know if you, or on Linux also, like things crash and then they stop working, and then you're like having to restart. Sometimes even restart doesn't work. So that key thing, it's called kernel. Okay, so it's the main program, it's the alpha program basically that takes care of resource allocation. Okay, the green things are resources, and applications, which are programs, which are processes, need those resources to do something. Okay, for example, like if you're training a machine learning model and you need a GPU or even CPU or memory, then that program, that Python program, asks kernel, hey, give me 5 GB of space because I have a ImageNet model or something, right? So what I'm saying is applications ask for resources and they typically get it, and there's also sometimes they may not get it because the resource is busy. So all that is managed by a kernel. So it's a really key piece of software. And it's heavily developed, and it's a fascinating topic in itself. That's the usual architecture, right? Now, let me go to a picture, which I'll go to the second picture and then come back to the middle picture. So given that, what virtual machines do is on the right, okay? On the right, you can see this infrastructure is like exactly those resources on your laptop. And this hypervisor is a program very, it's similar to, hypervisor program, which is like next to the kernel, okay? But it will ask kernel for resources, just like any other program. And then you have your virtual machine, which is, for example, this box here and this box here, and not box, but these are 3 virtual machines here. Okay? So this whole virtual machine, through this hypervisor, asks kernel for resources. Okay, but the cool thing about this box is that everything in there is controlled by the operating system inside the box as well. So there's an operating system here, which is not shown, but I think of it as infrastructure including the kernel. But there's an operating system here as well, which has its own kernel, and this kernel, for example, the VM you would have allocated like, okay, 8 GB of RAM and 50 GB of disk space and so on. When you, for example, when you create something a virtual box, for example, and so the kernel here is going to allocate resources to these apps inside the virtual machine, but the virtual machine itself needs resources from the host operating system, okay, which could be Windows or Mac or Linux nowadays. So there are two kernels, and so in that sense, virtual machine is really an isolated environment. It's literally like a machine, and that's exactly what Amazon rents to us on EC2 that we saw last time. Okay, so Amazon has some machines we don't need to know behind the scenes. And Amazon says, okay, you want a virtual machine, take one. Okay, because once we log in, we just see the guest operating system, which is the kernel guest operating system kernel, like the Ubuntu or Amazon Linux or whatever we choose. Okay, and then we run our app, and that's what we did last time. But behind the scenes, Amazon optimizes for okay, how many people on one actual machine and stuff like that. Okay, so that's the story of virtual machine, and I highly encourage you to play around with VirtualBox because it enables you to do a lot of things local to you and without like setting up actual physical machines outside. For example, if you're trying out like a client server interaction, which is web server component, like the first lecture, if you really realistically want to do it, you can have one virtual machine have a client and another virtual machine having a server, and you can make the virtual machines talk to each other through HTTP. Because each virtual machine will have their own IP addresses, you can actually from one virtual machine open up browser. You can actually ask the second virtual machine. That kind of gets closer to having a remote server. Okay, obviously you can just run everything locally with the Flask app, but that's like just local test, local trying out, right? If you want to make it more realistic, not just that was one example, but you can do many things, okay, including Kubernetes and all that. You can try it out. So that's the story on the left. Sorry, the story on the right, right? Now, what's the story on the left is that we don't need a hypervisor and we don't need a guest operating system anymore. Okay, obviously we need something else, which is the glue program. In this case, Docker, daemon or engine, what are you going to call it? An extra like JVM, right? That can take care of this process. Now these are processes. This is a process from the perspective of the host operating system, just like the 30 other processes that we saw I just showed, or on Windows when you see even on Mac when you see activity monitor or something, you can see some bunch of processes. So that's what these are. But they also have some level of isolation in the sense that the app inside, which could be our machine learning prediction app, like the Flask app, from the Flask app's perspective, it looks like a virtual machine or it looks like an actual machine from the app's perspective. Okay, but the reality is that there is no kernel, no hypervisor in there. Okay? So it's directly the resources it needs. This host kernel is what's giving that process the resources. Okay. So what would be without this container, right? So which is what we saw in the web server case, is that you directly run your app. Like host operating system. You drop the blue thing, you drop this bins and libraries. Binaries and libraries are just short form names, but they could be in the operating system itself. And you directly run an app. Okay, that app is just like a process. It will ask the kernel, hey, give me some resources, right? Like the first picture, and you could do that. That's another case. The whole point of doing this box is that it's portable, right? You can develop locally, create that zip files, the image that I was talking about, and you can run the container anywhere else. Okay. Otherwise, if you had developed locally without this taking care of this container image creation, then your app may run on your machine or locally. Okay, but that's not going to pay the bills, right? Your app has to actually run somewhere else and actually create value somewhere. Okay, so what matters is that your app running in production somewhere. Right, so whether it runs on your machine is kind of irrelevant. So it somehow kind of these types of technologies enable you to do that. Okay. Yeah. Any questions?
So
yeah,
we talked about security of virtual machines last time.
Very secure. Yeah.
Yeah. So how are containers? How much are containers secure in those terms?
Partly secure.
Maybe a little bit context here is so we were talking about HTTPS last slide.
Yeah.
We can allow anybody to log into our web page and then do whatever we ask them to.
And last time when we set things up, we said we're going to still talk on the HTTP protocol, just like we agreed on the slides. It's just that there was no authentication mechanism that we had, as a barrier.
Right.
The HTTPS is a more lower level technology that itself doesn't make your app secure in any way. It just makes the interaction secure. So if you have HTTPS enabled, the same protocol, HTTP protocol is what's, the get, post, everything is the same. It's just that your server, your client knows that when it's talking to the server, it is actually the server, and nobody else in between is masquerading as a server, or nobody else is masquerading as a client. Okay, so it provides a trusted channel. So this whole HTTP behind the scenes is trying to create a channel, kind of a continuous channel between client and server. Okay, it's not exactly continuous channel. It's like exchange of packets, but behind the scenes there's some mechanism to kind of keep them stable, because because your GET request may have a really large feature vector. It's not like the whole feature vector is immediately shipped to the server. It'll send part of it, say, are you ready to take the next one? Yes, and therefore you send the next small batch. And so that's how it works behind the scenes. But that's too low level for us. Okay.
So these containers will still go onto a virtual machine whenever we are deploying it.
Yeah. So for example, last time we rented an EC2 machine, right, we can install Docker there, and we can run the container in that virtual machine. That's what we would do. Like if you rent a bunch of EC2 machines on Amazon, you could run containers in there.
But are there any cases otherwise also? Can we run containers?
Yeah. So the whole point of us creating an image is we don't care about whether it's inside a VM or not, right? We can just create the image, which is the zip file corresponding to the container. We can just ship it to Amazon's managed service like ECS or Google's managed service GKE. And behind the scenes, we don't know whether it's running on VM, whether it's running on an actual, like a machine like this, or this setting, we don't know. We don't need to know, and we don't care.
Okay, so we just need to create a container, post it on Amazon or Google, whatever.
Yes.
And then we don't need to care about the server at all.
Yes. Yeah. But what does it get us? How is it different from being serverless? Is that you have a little bit more control on other things. In the serverless case, we kind of, it's all a little bit blurry. It's not like binary thing. But in serverless case, we were pretty much focused on our business logic, just that function, maybe some extra helper packages, perhaps. At least in the demos, we just did the bare minimum, just did hello world, basically. But serverless is like you don't even control anything else, like it's dependencies, non-Python dependencies, especially. It's unclear, right? How do you get non-Python dependencies? Python dependencies, at least you can add requirement in the requirements.txt, or maybe upload the Py files related. But so dependency management, if you need a little bit of control of it, then containers are the way to go. Okay. Yeah. Any other questions? So I wanted to just go with like 3 pictures, and the first one is the second one. Then we'll come back to, I want to go to the Docker. Sorry. Yeah. So now let's look at this. Let me just let's just look at the image, because this pretty much kind of gives you a block level diagram of what are we trying to achieve, right? What is the details? So basically, there are 2 programs here. There's a Docker client utility or command line utility. That's one program. That's just a way to interact with this software called Docker daemon. Okay, Docker daemon is the one which allows you to create these zip files, run the containers. And this is the helper, the blue thing that we saw in the previous figure. Okay. So how does it do? So the client, so there's daemon just means a service. Like it's actually a server also. It's a service. It's waiting for requests. It's not to HTTP protocol, but it's waiting for requests. Hey, tell me what to do. And the command line usually is saying, hey, build that zip file, build that image. And okay, it gets that instruction. Maybe it goes and builds that image if it's not there. And say, if you may say, hey, pull or get an image. Maybe you want an Ubuntu like image, then it will go and go out into the world and see if there's a Ubuntu like image from some standard registries. Like Docker itself maintains a registry or like this collection of images. and downloads it for you and so on. Okay, that's the split. Basically, there's a Docker daemon and there's a CLI utility talk to it. Okay, and then there's the third column here just represents registry. Here, this logo is for Docker itself. So the company itself maintains this registry as a collection of images. People can submit, and it's just like GitHub for code. Username / my image 1, my image 2. You can keep some images, and other people can use it. Obviously, there's some free tiers and paid services and so on, but that's the collection of images. Okay, or the zip files essentially. I'm calling it zip files, by the way, informally. I don't think that's the way people explain it elsewhere, but that's what they are. Just files. Okay. Now, what is? Let's focus on the center column. So the client and the host, since they're like two programs, they don't need to be on the same machine and stuff. But let's say it's on the same machine. This host, this program Docker daemon is always running and can maintain can help you delete containers, start containers from images, which is what I said is the key concept. The image is a zip file from which an instance of a running program is called a container, and manage both images and containers, and also everything else associated with it. Which is, you have programs, they may need disk space. They may need to store the data set to actually do the training. For example, let's say you're doing a training job inside a container. Or they may need network access. Maybe they want to, save data some third-party location. Or they may need, maybe one container has your database, maybe MySQL or Postgres. The another container has your Python app, and maybe you need to kind of process data, do some ETL activities, and process data into post-processing. So there's the network and volume as in like disk. These are aspects that also need to be kind of provisioned and taken care of, managed, right? So that's what the Docker daemon does. Okay. So just think of it as like a behind-the-scenes program which takes care of management of containers on a single machine. But it's a little bit more manual, and that's where orchestration software like Kubernetes can do it in a little bit more scalable way. Okay. Any questions here? So we'll get into now the client side and actually do the demo, so that we'll actually go through the getting started guide, and that plus my commentary hopefully will kind of clarify a few more things. But at this point, I just wanted to say that these are the two programs that we'll install, and one of the programs, which is the key one, Docker daemon, is the one which is taking care of creating of the zip files and running the zip files. Now we'll kind of disambiguate what is this image and what does the content look like and so on in the next in the demo that we'll do now. Okay. Any questions? Okay, as I said, instead of looking at our nodes, we'll directly look at Docker's website. So this is the, I guess, Docker's page. And in fact, they're trying to market it everywhere. So you can see the first, this first, I guess, I don't know what this is called, but first box is literally about AI/ML, right? So maybe it was not the case 5 years ago, but today it is. And this Docker Hub is the registry that I just mentioned. So you could have your username and my app, and that could have the image, the zip file I'm talking about, and people can download it. So actually, let's, and this is there, I guess, the company page. Let's actually just go to the documentation. You can just go to developers and docs to get there. And we have to do two things. First is install something which can get us the Docker daemon. The easiest thing for you all to do is to install what is called Docker Desktop. Okay, so I will sorry, I'll start the getting started page here, but for you to kind of follow through, it'll be good if you install Docker Desktop. You can also install in various ways. I don't want to go through the installation process now, because Docker Desktop is just double-click and install. But if you want to install, if you have a Linux machine, which I don't think many of you have, then you can also install via command line. Okay. So let me briefly mention. So this is the Docker Desktop links here. There's 3 links for 3 different operating systems. You can also install just, Docker Desktop includes a UI for you to kind of click and delete, and you can see containers and you can see images and so on. Okay, so it's a little bit more accessible to beginners. So I would recommend doing that. Otherwise, we just need Docker Engine for today's demo. Okay? Docker Engine's installation links are here, and if you click on it, there's a huge bunch of installation. Okay, you want to install it on various types of operating systems. This is the instructions. Okay, so if you can, try to install it soon. So what we'll do, sorry, where did I go? We go back to get started. So it has a lot of parts. We'll just try the essentially part 2 is the only important thing for us, and then we'll go back to we have a Docker example, or we can easily containerize the stuff that we saw last time. Okay, I want to go through this example. This has a pre-made app. It's not a machine learning app. It's just a to-do list or something, but it just gives us the idea of the rest of the things, and then we can do the same with our ML stuff that we've been doing. Okay, so part 2 is about what we're going to do today. Okay, this. So let me just zoom in. Okay, so let me, as here there's a, more details, more technically correct details of what a container is and so on. So it's basically a sandbox. So the sandboxing means it's a kind of a secure, like for example, your Chrome tabs, for example, they're kind of sandbox environments. Programs running there, which is essentially JavaScript programs, they can't just randomly go and corrupt your disk or anything like that, right? So it's a kind of the program takes care of it. And similarly here, containers and therefore Docker also takes care of things. But the strongest sandboxing is just to run a virtual machine, or actually a physical machine, which is completely isolated from critical other things. Okay. So there are a few words, as I said. There are two. Container is a process, which is actually a program. Image is a, as I said, is essentially a zip file, which essentially kind of wraps around your zip file, which provides all the binaries and libraries, which essentially means it also kind of shows up as like a file system from your program's perspective. So from your program's perspective, the zip file provides everything so that the program will see, oh, I'm actually in a operating system, but you're not. You're inside a container, which could be one of the many containers running on that, even a virtual machine or an actual physical machine. Okay. So, but let's not get into the technical details of these yet. We'll try out how to containerize as an example application. Okay, so as I said, we only focus on 2. We can do the other ones as well, depending on interest, but let's do 2. And for that, it says you need a Docker Desktop and you need a Git client. And we've already done Git clone before. If we don't want to do Git clone, we can do a download zip, right? We've done the download zip part in lecture 1 also on GitHub. Okay. And then you just need a text editor. IDE stands for Integrated Development Environment. So VS Code is a tool that many people use these days. There's also PyCharm and many other ones that you can use. Okay, so let's just run the Getting Started app that they have in this tutorial. So first step, git clone a particular repository. Okay, so we just need to clone this. So let me. Okay, so what do we have? So I just have this. We have our own repository, ML code examples. We had created from before, and credentials are just a .pem file or something that I got last time when I created a virtual machine. So and then some notebook that we had just for like when I was doing request stuff. Okay, so was not the I'm not able to copy. Okay, so we're just getting that repository. It's a repository which doesn't have anything, actually, nothing to do with Docker. In fact, let's go into getting started. So if you see, it has nothing to do with Docker. There are a couple of folders there, SPEC and SRC or something. and then three files, okay, readme and yarn.lock and package.json. So this app just happens to be a JavaScript app, okay? We don't have to know anything about it, so let's ignore it. Okay, we'll change it to a Python app in the next iteration. So it's just some program, and it turns out it's an app that we can run in a browser. It's just think of it as HTML file, okay? It's just that we don't want to run it on the local machine. We want to containerize it and then run it. Okay, that's the focus here. So for that, this suggestion is there are two steps. Okay, first is to build that zip file, and the second thing is to run the container from the zip file. Okay, that's kind of clear, right? So we have this code. We want to first build a zip file, or I'm calling it a zip file, but it's just an image. Okay, so how do you do that? The way you do it with Docker is create what is called a Docker file. Okay? So it's a way to say, how do you create the zip file? It's just a text file. You just need to say, start from this and do this, and this is how you zip it up. Okay, so let me explain this Docker file, the contents of this Docker file, text file. Okay. So firstly, it's something about syntax. How do you specify? So they have a way to, suggest like how to build this zip file or this image file. Okay. So what is the interpretation? There are a few keywords or words that they use. Firstly, you need to start from some base image. Okay. So from some starting point. Your starting point is not build everything from scratch. Okay. The starting point is, hey, get me an image which has Node. Node is just the name of a JavaScript runtime software. So get me an image. Okay, this is like get me an Ubuntu-like image. Okay? And then add some bells and whistles which I have, which is specific to my app. Right. So saying, okay, start from some Ubuntu-like thing. In this case, it's actually not Ubuntu; it's called Alpine. But Alpine Linux, Ubuntu Linux, they are all, for us, it's just some Linux starting point. And then create a working directory called /app. Okay, it's just so that you can kind of keep your stuff in one folder. Okay, and then copy everything into that folder. Copy dot, and dot just means copy everything into that folder. What is that everything? That getting started app folder had like those 2 folders and 3 files, right? So copy everything into this. So what are we trying to do? We're trying to create this zip file image, which should look like a file system from the program's perspective. If it's a file system, then it should have like a folder and files, right? So that's what we're trying to do. So copy all my project related files, which are the yarn.lock and all that, into this location. And then generally the way you instantiate, you want to kind of set up the necessary dependencies for this JavaScript program to run is running just very similar to pip install. Here we're just going for JavaScript, it's called yarn. It's not the only way, but yarn install things. Okay, so that's all that step is doing. And then command this line is saying once you've installed stuff, it's like Python flask.py. It's very similar to that. It's just saying execute node and source/index.js. Okay, so why is it like giving a list, like a list of strings and not just a string? It's just you can actually give a string as well. They just chose to give it as a list of strings here. Okay, and then expose port 3000, which is fine, 3000, 5000, something like that. That's it. That's the specification of creating this image from which we can easily spin up a container, which is just a process. Okay, you can kill the process and you can recreate the process. Okay.
3000 is the identification for server.
3000 is just the port. I mean, it's not it's an identification for the container. So from the container has to listen to requests at some port. So server has its own ports. Okay, whichever server in which you're running this container. The container will also have ports through which it will talk to other things. Okay, so we'll map the container port to the server port so that we can, because we from the browser can only access server ports, not the container ports. So there's some connection we'll do, but that's a detail that we'll get to in a second. Okay, I'll repeat that. But this 3000, remember our Flask app by default starts at port 5000, right? So it's like that. Instead of 3000, you can think of this 5000 if you want.
Yes, I'll just reiterate just from my understanding. So we cloned the getting started app from GitHub.
Yeah.
We went into the directory.
We will create this. We haven't yet created it. We'll create this. Yeah.
We went into the getting started app directory.
Yeah.
And there we created the Docker file.
Yeah.
And we're saying that within the Docker file, copy everything that is present in that directory.
No. In the Docker file, we just write these 5 statements or 6 statements.
And that will copy everything from the getting started app, right?
This, yeah, when we want this set of instructions is read by the Docker daemon when we ask it to create that zipper. Okay. Or create that image, and therefore an image will get created. That's step 1. Step 2 is use that image and start this container which has this app. Okay, we'll do that two times, one with our machine learning code and this one with their instructions, just to kind of revisit the same ideas. Okay, let's especially, I don't know, some of you maybe already like know this, but if not, it's a good exercise to try it at least once or twice. Okay, yeah. So let's actually just copy this. You can use any editor. I'm just gonna use Vim, but that's because I want to keep it in the same area. So Docker file is a canonical name that you can give. You can give other names, but this is what everybody gives. So just like VNV is just the name of the virtual environment folder, you can give any other name you want. Okay. So this is our Docker file. Okay. And yeah, I might have built the same image before, so I need to use a different name. Okay, let's see. Okay, so as I said, step 1, we want to create the zip file. Now we have the instructions. We actually want to create the zip file which has this app. Okay, remember what is our app? App related files. In Python case, we only had one Python file typically. That's what we saw in the previous couple of classes. But you could have more files. In here, it's just a bunch of these files, and we can also copy that. That doesn't matter. So we want to copy all this into that image. Okay. So I will use sudo, although the instructions don't say sudo, because I need elevated privileges in my case too. But sudo is not a command that's available everywhere. In Mac, it is, but you may need elevated privileges. But with Docker Desktop, I think you don't need. You should let me know in your when you're trying this out. Sudo docker build. Build is a verb. So this is the CLI utility which is talking to the Docker daemon. Okay. So this, as in the second word here, is the program, which is the command line utility. Okay, which is going to talk to the Docker daemon through these commands. Okay, Docker build something, and when we build something, let's give a tag or a name. Okay, of what is that we want to build. Let me just build. Let's call it Teja. Okay, and press enter. Oh. Isn't that not the build? I forgot it. Dot means the Docker file in the current directory. Okay, we need to specify where the Docker file is. So much authentication, and so you'll see a bunch of details here. So let's ignore much of the text, but so here's what happened, right? So here you can see building took 11 seconds, and apparently I have that image node Alpine or something in cache, but if not, it will actually fetch it from some Docker registry, right? The docker.com basically, and then it's basically showing what, step 1, get that image literally from somewhere. I get that Alpine thing. Step 2, working directory /app. Step 3, I'll copy the current files into that thing. And step 4, run basically pip install everything else that is needed for this app, and that's it. And then I'm going to name it as, basically Teja, but that's all we want. Okay, so now we build it. Now the only thing we need to do is now look at it and then start a container based on it. Okay. So first, let's look at it in a sense. How do you know it's built, right? So in my case, if I type images, I'll see the images. In fact, I ran the getting started one before. The Teja one is new one, but so these are the list of images available currently on my local system. Okay? These are the two images I've built. Okay, but I only built one in right now. So the image is built. Now what we want to do is run a container from this, like start a program. Okay, that the program in our case, from the, as I said, the program's perspective, it will see a file system, but it's all it's not a real file system. It's that box that we saw in the slide. Okay, so how do we start the so this okay, let's put 5,000 to 3,000. And then okay, let's actually go back to the instructions so that I don't mess it up. Okay, here it's saying a few more things, but okay, let's just do it this way. So okay, so I ran a little bit different command, but that's because I wanted to minimize some extra bells and whistles, because the other command has a little bit more things. So Docker run, that's again an instruction. The CLI Docker program is instructing the Docker daemon, hey, I want to run a container based on this image called Teja. Okay. So instead of I could have used the other image, but so because I did not use the extra argument D, so it's not a background process, it's actually a foreground process. So it has locked my CLI here. I will have to open another terminal or something to kind of do more. Okay, so let me do that. So let's see, first of all, curl local host 5,000. Okay, this is also blocked. Okay, so I got some text. So I'm able to access something at that port 5,000. Okay, remember we did give 5,000 as an argument here. So that is the server port, the port from which any other program on our operating system can access things. Okay, that port has been mapped by this Docker daemon to the containers port, okay, which is 3,000, which is, remember, expose 3,000 something. And so that's how, when we refer to 5,000, the container is being asked to respond to my request. Remember, curl is a program to make a HTTP request. We made a HTTP request saying, hey, fetch me whatever you have at 5,000/root location. I gave a full HTML document here, right? So it's some React-based app, it looks like, but that's the HTML document. So instead of that, we can obviously go here. Right, so this is the app. I mean, we'll kind of redo this whole process with our thing in a second. This is some app which does some UI related thing. Okay, so to do this type of thing. So that's how you create a container or create a program, a container from your program, starting program, which is isolated, say at least partial sandboxed and isolated. Okay. Now, obviously, this doesn't show the really true value of Docker or containerization. The whole point is that image that you created, you can ship it to registries and you can run it in AWS or DigitalOcean or whatever, whichever places you want, okay, on other laptops and so on. And those other laptops or other locations, they don't need to install anything beyond just a Docker runtime or Docker daemon based. As long as I have Docker daemon, they can run your thing. Okay, they don't need to install anything more. So that is really cool, because otherwise, if you don't do it without containerization, then you'll have to pass on the requirements of text, and everybody else has to install the same requirements of text, which is fine. You can create a virtual environment and you can install all the dependencies there. For example, in our Python case, but it feels a little less isolated than doing it this way. Okay. Any questions about this? Okay, so let's actually. I realize I should have done this in the Jupyter perhaps instead of tabbing between. But is the font size big enough? I think. Okay. So let's clear this and let's actually go to our MLOps code examples. We do have, I think, a Docker example. Let's probably just look at this. Okay, so we are in the Docker example folder in our code example. So let's see what all is present, right? So it's the weather service and Docker file. I don't even know if the weather service works, but we can try it actually. First, let's try it and then we can create a source. I'm gonna ideally, and this is where the it doesn't even tell me what packages are dependencies here, right? So okay, let's actually do it in a proper way. So okay, let me just not do random things. Let me open the Jupyter environment and do it there so that I don't tab between 100 different things. Making a lot of noises, but all I'm doing is just I'm just activating the virtual environment and just trying Jupyter Lab. Okay, so okay, let me just go here. So you can see that it actually needs a bunch of installations, but this is a program that is supposed to query another API behind the scenes and tell us the weather of any location. Okay. I think somebody tried this before, but let's actually. So what are the installations that are needed, right? So the proper way to do this is actually have a requirements.txt at the minimum. So you need Flask, GeoPy, and requests, I think, is by default available. Yeah. So ideally, you should be doing it this way, right? So you should be actually creating a virtual environment and then doing pip install of these requirements. But since I already have one virtual environment, I'm already in a virtual environment. Let me just use it. But actually, this terminal doesn't know the virtual environment, by the way. Oh, it does because that's the only, okay. Then let me just also check. Pip is also the same place. So Flask is already there, and then we install GPI. Okay. I just want to see if the app works. Okay, port 5000 is in use. So let's actually change it to, because we're running the other. So I just changed the last line to change to some other port. Okay. Okay. We did not pass anything. So I think it's called message, but work. Nope, did not work. Let's go back here. Request time out. Okay, so let's not use this then. I'll just use the regression one we've been using so that we don't, because this is not the focus of okay, same issue. Okay, this one. Okay, this app is working. I mean, I don't want to make the app dependency complicated. So I just wanted to check that the app works. And now we probably also have to slightly modify the Docker file, but that's okay. So this is the Docker file for us. Okay. So previously it was a weather service. I'm going to remove irrelevant things so that it actually works for a regression case. So it's the same as before, right? So that previous app was the Node app. Instead, we want to start with some operating system. Let's start with Debian. It can be also Python. Okay, Python also has images. So you can say Python colon 3.7, Python colon 3.11, and you can directly get a Python environment by default. So you don't have to kind of install things here. Actually, we're starting with Debian, which is like Ubuntu almost. And maintainer, we can drop it. And then we're saying, okay, once we get that image, apt-get update is just to update so that apt knows apt is the program inside many of these Debian and Ubuntu type systems, which kind of knows how to install packages. Okay. And then we're saying install Python here, install Python 3 pip, or Python 3 by default comes with the Debian, whatever, but install Python pip, and then do we need this? I don't even know. Let's just drop these lines. And we just need Flask. And pip install Flask. Okay. And copy, we explicitly here saying copy that particular file, but we can also say dot and dot. And also we are not even changing the work directory, which is bad practice, but we can also change just so that in which directory you want to copy. Okay. And then here we are saying entry point instead of CMD. It's totally, it's just another verb for starting something. So yeah, so is the Docker file clear? Like what do it's exactly the same instructions that you would do if you were doing it outside Docker, or if you want to kind of list everything. And then sudo docker build minus tag, in this case, regression, and then use the dot is needed for like saying the Docker file is the current directory. Okay. So okay, so it already got step 1, and now it's saying, it's doing step 2. And there could be errors, by the way. If you have errors, you can honestly run it to show. The cool thing is with this Docker thing, if there's error in some step, you don't have to, it caches previous steps, so you don't like lose valuable time. So it's actually right now setting up the whole Python. Instead, we could have started with a Python-based image actually. Okay, so we built that image. Right. So these are the 3 images. Right. And actually you can also do PS. PS is like very similar to list the processes currently running processes. And these are the 2 processes running from some time ago, actually. I ran the getting started in the default configuration, so it's running there. And this is the one we started a few minutes ago. We can actually now so what was that port 5001? 1 to 5001 of regression, right? So we can run D. D means in the daemon mode, so you get back the prompt. The only difference, the extra D is just letting you get back your prompt so that you can do other things in the same time. Okay. So let's run it. So if it ran in the sense that the container started, we don't know whether the container after the container starts, it actually is in a good state or bad state, but at least this is the content. This long string is the container ID. Okay. So for example, here Docker PS, you see, these are the container IDs. These are basically like some truncated version of this whole thing. Okay, so if I for example run sudo docker ps again, you can see it's the oh it died. When I say so it exited already. So that's because the command is wrong. What is it called? Regression. Okay, so what do we need to do? We need to build it again. So that was quick because previous steps were cached, and let's see if it's still running. Okay, so this one is still running, and we can try to. We killed the 5001 process, right? I think. I think this is because of. This is because of some issue with. Okay, my mouse is. Let's see. So this is running, but I think it's an issue with not specifying something. Okay, let's see. But this will fail because the port is not available. Okay. I think the right verb is before removing. I think I need to stop it. So let's just. Rapid skill. Okay, so I rebuilt it with explicitly specifying the. So this is something to do with some permissions. That's why this is not. Okay, so the host IP address is not there, and so there was some security aspect, and so things didn't go through. So this is working on. So this app is being served inside that container. Okay, the only reason why we'll talk to it is through that. Through the port forwarding or whatever, port mapping. So now, I mean, we did it for a simple program. It just needed a Flask as a dependency, but you can imagine 100 different things, PyTorch certain version, CUDA certain version, for example, if you're doing deep learning. So in those cases, it's very much more helpful, especially from the ML perspective. Obviously in software, it anyway has a lot more mileage, right? So any questions here with what we did? I did it twice, one with the app in the getting started part, and we did it with this. Actually, the getting started has really good ideas on, really good ideas on how to do a few more things, okay? For example, if you want to persist, so right now we containerize the app, okay? But what if we wanted to mount a directory from our server so that maybe that has data in it and we want to kind of even if we kill the container, let's say the container is logging something, who all requested predictions. Let's say there was a log of these are the people who requested predictions. If you naively log it, it's going to log into that container's file system. And if you kill the container, the data is gone. Okay. If you want to persist the data, there's a way to do that through Docker volumes. That's I guess step 6, basically, for example. So these are ideas to kind of which help you kind of improve the whole experience. Okay. Yeah. Any questions here?
How big can the containers be in terms of
They're just processes. So they can take, if you give, they'll take the whole as much memory as you can give them. Yeah.
where are they taken?
From the kernel. They ask, so all processors on your computer ask kernel, hey, give me some memory, give me some compute, give me some
From our local systems.
yeah, your laptop's kernel. In my case, my laptop's kernel. Yeah. So when I typed something in the browser, the browser was asking the kernel, hey, give me access to the keyboard resource so that I can actually get the keystrokes.
So, but
Right.
when we send out Dockers to, let's say, some other virtual machines,
Yeah.
they would sort of take again the memory from that particular virtual machine's kernel.
Yeah.
So if there's a difference between the memory requirements,
We didn't specify the memory. So it's just a process, right? So if you run, so think of it as if we didn't Dockerize, I run Python class.py, how much memory does that program have access to?
I mean,
Everything.
definitely py files does not have memory, but if I start mounting data on it, that will take up memory.
Mounting data is unclear what you, so if you want mounting a directory in your file system, yeah, that is just mounting. It's not like reading data into memory. Mounting just means persisting data beyond the container's lifetime. How do you persist the data? Just keep it outside the somehow have the data outside the container on disk, so that even if the container dies, you have that data. That's all it means. So it's not that the data is in memory or anything. It's just you can always have a huge CSV file also be copied and read in memory when the container starts, and obviously the amount of how big the CSV file is going to influence how much memory it takes from the kernel. Yeah. Okay. Any other questions? Is it complicated? If it is complicated, as I said, just refer to this getting started tutorial. It has a lot more information on like what does each step mean. But why do we care about this is that we saw two extremes, serverless and really spinning up a virtual machine on EC2 or whatever, and started the same simple prediction model, regression model, but doesn't have to be that. Right? It could be a random forest model or something else. And so in between is the container technology. And it's actually very, very popular, very mainstream with everything these days in machine learning or otherwise. So it's worthwhile learning what it does and what role it plays, and even simple examples like this. So if there are no questions, I will want to switch topic to Git. Is one of the tools that I wanted to cover last time, but I will cover today. Is that fine? Or any questions about Docker? We're moving away from Docker. This is like we just barely scratched the surface of Docker, not Docker specifically, but container technology. Docker is one vendor which provides this type of flow, but there are other vendors, Podman and other approaches to do this. If there are no questions,
application of moving Dockers to Amazon servers.
Yes, so there is in the notes. We can move the image to Amazon's Elastic Container Registry. ECR is what it's called, and from there you can read it into your Amazon. So those things make sense when you have like a very controlled environment where for example, if I try to upload this to Docker Hub, by default it's a public image that anybody can download, and unless I pay and have a private repository, just like GitHub perhaps. So if you upload something to Amazon's registry, Amazon doesn't maintain a public registry as far as I know. So you should upload it to your account so that it's if it's your IP, your code, your proprietary thing, especially for businesses, then you put it in ECR or whatever. And so other teams in your machine, your organization can access it and use it, right? So that makes sense. So the upload process is just dependent on each vendor. I think in the notes there was an upload process for Amazon, but I would obviously recommend to read the documentation. We can do that, but I think it's just not very useful and instructive at the moment. Yeah. Any other questions? So I do want to quickly talk about Git because it's something that we have used from day one, and we want to kind of learn a little bit more about it. So Git is a really nice technology for version control, just like Google Docs, Microsoft Office, Box. I don't know. All of these have version controls. Like they kind of snapshot something before the change, and then you have after the change, and so you can go back, revert, right? So Git is the same for code. So we can, so the way you think about version control is again just like Docker's case. There was a Docker command line entity at the bare bones. For Git, for this version control, you have a command line entity called Git. Okay, so for example, we did run. So when we run git clone, right? Git is a CLI. Clone is the verb that it understands, and then if you give a URL, it clones the repository from there. Okay, the command line utility. So what does clone? We have seen many verbs. What does clone mean, and a few other verbs we will see. Actually, we only see one verb, I think, clone. So let me actually go back to a slide deck. I think Git is in the just a bunch of points that tell me how to kind of mention this. But what we want to talk about in the next 5 to 10 minutes is just about this version control aspect. It's a very mainstay in software world. Okay, so if not Git, there were previous incarnations and as well as competitors to Git, which all achieve their whole business purpose or value purpose is to version control things so that everything is snapshotted. Okay, just like models need to be snapshotted, your documents, who edits what, all that, right? Same idea. There's a difference between the Git, the technology itself, which was invented by Linus Torvalds, versus the vendor, in this case GitHub, which is just a vendor that kind of helps you work with the technology and provides some social networking aspects. Okay, professional social networking, right? But nonetheless, it provides extra things on top of the core technology. Okay. So GitHub is not the only player there. I don't know if you've heard of the company Atlassian. It has an offering called Bitbucket, which is heavily used. GitLab is another multi-billion-dollar company in this space. And you can also self-host, as in you can literally, if your organization doesn't want to have any code going outside your infrastructure, and if your infrastructure is already on premises, then you can install something like Gitea or some other software like this. Okay. So what we want to do, again, a very basic, we already have a repository, MLOps code examples. We'll try to work with that and show this version control idea. Okay. So for that, there are actually many, I can't edit it because I'm not signed in. Okay, so there are many verbs here in addition, including clone. So here I'm showing a few names. Pull, push, clone belong to one category. So cloning is like the first time you get it. Pull is like, oh, if somebody else updated it and it's updated in the remote location, then pulling, and also another verb called fetching can update your copy of that. Okay. Push, as the name implies, if you made some changes and you said, okay, these are the new changes, and push it back to some location. That's what the verb does. Now, and the next category is commit. Okay, commit is like when you made the changes, you want to snapshot it. That's the commit. Okay, so pull, push, clone are one set. Committing is like snapshotting locally, and then the only couple of verbs left in this page are branching and merging. Okay, that's a little bit more advanced. So we will do that, and I will discuss them while doing it. Okay. So branching and merging are also related to what is called a pull request. Okay. So pull request is also something that I'll show you while doing it. And pull request is a name that GitHub gives it. On Bitbucket, it's called merge request. But these are just requests for somehow merging code bases. Like, for example, there were two developers. At some point, they're working on feature 1 and feature 2. At some point, maybe both are features of the same program. they need to be, your code base has to kind of unify, right? So that's the process. Okay, that's the third bucket. And optionally, as a bonus, since many of you probably have tried GitHub before, you should try GitHub Pages, which is a free way to get a website up for your own usage. Okay, if you want to. There are other topics that we'll not get into, but actually super relevant for MLOps, actually. Also not just MLOps, but also general software engineering. Okay, that is the idea of continuous integration and continuous delivery. Okay, continuous integration. So the word integration should kind of tell you, okay, there's something called integration test, perhaps. Okay, continuous integration is all about testing every snapshot. So every time a feature, your dev team introduces a new feature or some enhancement, there has to be a continuous integration. Means there's automatically a trigger of tests to be performed. Integration tests, unit tests, fuzz tests, whatever types of tests you want to do is automatically triggered, and immediately you get to know whether that new update introduced bugs or did not. Okay, that's continuous integration, and actually it is something that is highly valued in many software companies for sure, but may also make sense for ML. Like you don't want your model to completely, like, for example, you build a new model, but you can immediately run tests, as in like you can run it on some test data and report AUC values, and if AUC values dip, then perhaps immediately you can trigger that, hey, this model is like not up to par, right? So that's what CI means. Continuous delivery is even more harder. That's more like, once the test pass, you automatically trigger the updated software to be dispatched. Like, for example, package it into a Docker image and start running new containers instead of the older containers. So that's even more complicated. Not many organizations do it, perhaps. Some are, obviously the top tech companies perhaps do it, but continuous delivery is like really pushing the new software once it passes the test in front of customers as needed, or customers or other teams and so on as needed. So that, I think, is like not very critical. I think the critical part is continuous integration. To summarize, what does it involve? It involves basically doing tests. Okay, and in Python, there's a really good library called PyTest that maybe I'll show as one of the tools of the trade in some subsequent lecture. And why did I go into this tangent is because GitHub, as I said, has extra things on top of Git. This continuous integration is one of those extra things that you can do through a service called GitHub Actions. Okay, and so if you're interested, you can try it out. Actually, that could be also a project idea to try out GitHub Actions and understand how it works. Okay, so there's other advanced topics, and in fact, one of them is Copilot, and it's actually not related to Git, which we are discussing now, but Copilot, if you've not tried it, is a LLM, large language model based derivative, which can help you it's basically a better version of IntelliSense. I don't know if you've used VS Code or PyCharm or some of these enhanced IDEs. You can actually get autocompletion and many other things, right? So Copilot, if you've not tried it, is basically a way to generate suggestions through suggestions from any AI solution. Okay, and so it's fascinating to think about how did they deploy Copilot and how is it able to have such low latency, such high availability. What is the architecture behind how the company doing it, right? So anyway, Copilot is an AI solution that is also part of GitHub's offerings. Okay, let's come back to our pulling, pushing, and committing first. So let's actually go back here. So let's type git status. I did not show the status command before. Status is just like, what is the situation right now? Because before I start making changes, I want to know if there are already some edits that are made. So it says here's the situation. Okay, once I downloaded this repository 2 lectures ago, right? After I downloaded, I made a bunch of changes. So I changed Dockerfile. That's, I guess I just did it today. Apparently, I changed Flask Weather Service because I added that port. And I also changed simple regression service. Okay, there was probably some extra lines and I deleted it. And there's also a simple regression service that I have added in this folder. Okay, because remember I copied the simple regression service from another folder to this folder. and I also made a requirements .text file. Okay, so this is what it's saying is the current situation. So remember, this is like saying your previous snapshot to now, things have deviated. That's what it's saying. So we let's look at requirements. So let's actually edit the requirement so that it's actually correct. So we're going to change this example to just involve Flask. Okay, so just involve Flask and regression. So requirements, I feel, sorry. So what am I doing now, right? I want to make a new commit with some better code here. For Docker example, since the regression example works better and is simpler, I'm gonna have the regression example in this folder. And so then my next snapshot will have just this and remove the other ones. Okay. So first of all, the weather service, I don't care. So git rm Flask weather service. And since it was already modified, minus f means like force, just delete it. Okay, so it says okay, some operation happened, and for me to know that, I can again do git status. It says you deleted this file, these two have been modified, and these are untracked. Okay, so
also change the requirements.
Yeah, so but they're untracked. So I changed them, but they were not in the previous snapshot. So requirements file is something that I created newly, and unless I ask it to start tracking it, it will not track it. Okay, so and similarly, this Flask simple regression service is something that I just copied it over, which means it's a new file essentially. And you will say, okay, why do you have to copy? It's already there in the same repository. But let's keep it simple. Let's so what do? We want to do a commit. Okay. Remember, pull push we will do in a second, but we don't have to do it because we can do it, but it's going to be redundant. But let's do the commit. That's what we're focusing on. Okay. How to create a snapshot. So git add. We're going to add the requirements file. Now we want to add it to our snapshot. Okay. We are creating this. Hey, I made some changes. Now let's curate it and then create a snapshot. Git add requirements and git add the Flask simple regression service. Okay, so now let's clear this. Actually, things are not okay. Git status. So what is it saying? It's saying that you modified these two, and these are changes that you have added, which are ready to be committed. Okay, the ones in green are ready to be committed. So if I just do git commit, then only those will be committed, not these. It says changes not staged for commit yet. Okay, they have changed, but if you don't add it to this snapshot, for example, if they're unrelated changes, okay, then it's better to do two commits, like one related to one, the other one related to other. One of them is actually a related commit, so I can do git add Docker file and say, okay, now these four are actually related to my effort in improving the Docker example that I have. Okay, so now let's just make a commit of that. Hey, we changed the Docker example to with some improvements. Okay, so how do we do it? Git commit is the verb, minus m just for a message, like you want to give a message, like something, what is it about, right? So improves the Docker example, yeah, and adds a requirements. Okay, let's just say something. So press enter. By the way, you don't have to do it by the command line way. GitHub also has a GitHub desktop. It is an app through which you can click and do things. But here you see the command line way. You can practice the non-command line ways as well, if that's easier. Okay, so it says, okay, we made a commit, right? So if you look at git status again, let's ignore this other guy for now. Okay, we'll come back to that commit in a second. Let's focus here, right? We're on branch master. Master is like an old name for like a default branch. You can call it master, main, something, any name, it's fine. it says it's my current commit, this copy is ahead of a remote copy by one commit. Okay. How does it know the remote copy? Because when we did the git clone, it knows where we cloned from. Okay. That's the remote copy it remembers. And I have made some progress. So it's saying, hey, you're ahead from the other one. Okay. It doesn't have to be, and by the way, the remote one doesn't even have to be in GitHub. Okay. The remote one could be in your laptop or in somebody else's laptop. As long as I know I can talk, I can hear, like check like what's your status. I can know whether I'm ahead or behind you. Okay. And Git, by the way, is a decentralized technology in the sense you don't need GitHub to actually work with Git. You can just have a Git kind of a protocol between you. It's just that you'll have to have, again, a client server type of interaction, which is, I guess, non-trivial at the beginning, but yeah. So, so we have a commit, we made it locally, we made the update. Then let's use the verb that we said, git push, to push this commit back to GitHub. Okay. So you can do so origin plus master if you want, like where to push this branch. Okay, maybe I don't have permissions. Okay. Okay, let's just try git push. What happened? Okay, I made a mistake with the extra arguments. So this extra command that I did was just to see, oh, is actually like linked to that remote thing that I copied from. So don't worry about that. So if you just, you made a change, you made the local commit, it already tells you that you're one step ahead. You can just say push. Therefore, the remote one now also becomes one step ahead. Okay, this is the coordination part. Between, like, especially makes sense for between developers. So actually you can see that if you just go to our, not this one, not even this one. We don't have it, is it? Okay, this is the one. So, right, so this is the commit made 3 minutes ago. Improved the Docker example. In fact, GitHub provides this UI, right? So you can actually click on it and see what files changed. Okay, it said 2 files got added, 1 file got removed, and Docker file got modified. Okay, so it's a good way to kind of get used to, okay, there's changes. It's hard to track it down in some lab notebook, or or physically name it as version 001, version 002. That's just not a good, I mean, it's fine, but it's a suboptimal practice. So you can, I would suggest, like, start playing with this. So, okay, I don't want to take too much time. So pull and push. Pull is just the opposite of push. Like if there is an update on the other side, just git pull will update yours. Commit we just saw. The branching and merging is the only thing that we did not. So for that, I want to show, we'll do that with the remaining. Actually, we can't do with the remaining one. Let's see. Let me go back here. And wow, it's taking so long. Okay. So okay, so what I'll do is I'll create a new directory where I'll clone it again so that I can show the branch cleanly, because other directory has one more modified file, which I don't want to touch. Branch example. So git clone. This is exactly the same operation we've seen a few times. And if you do git pull, oops, sorry, we need to be in that MLOps thing. And if you do git pull, it says everything is fine. Okay, if it was not fine, you would get the update. Okay, so now, what is branching and merging? So generally, when you do develop a feature, if 2 developers are working, ideally don't want to work on what is called the same branch. Okay, so think of a branch as think of a tree first of all. So branches are, for a physical tree we know what it is, but think of snapshotting system as the way it works is you start with the root of the tree as like the starting point of this project. Okay, and then every time you're making a snapshot, it's like putting one dot on like the trunk of the tree, right? So you're putting dots, but at some point, there's a if you were the only developer, you would keep snapshotting and there will be only one trunk and there's literally one branch. Okay, trunk just transformed into a branch and then that's it. Okay, branching makes sense when you have one more developer perhaps, or you yourself want to, from a snapshot, deviate for some time because you're developing a completely new feature which you don't want to kind of immediately kind of use the or stable like the main branch or master branch. You don't want to mess it up. Okay, it's working but it's suboptimal, inefficient, whatever. So you can branch out, as in from that some snapshot. Okay, you can branch out and make your improvements and have commits there, and then once you're satisfied, you can merge that update back to the original one. So the original branch or tree is not affected. So what do I mean by that? So you can see that MLOps code examples. Okay, I don't know if this is the right. Okay, so there's only one branch in this repository, or in this Git repository is just the name of this folder plus this tracking system. Okay. By the way, the tracking is all happening in a folder called .git inside this folder. Okay. So there's only one branch. So we have made some 30 odd commits in this. So there is no, I've been making because I'm the only developer on this repository. So I'm making commits. Let's say I want to make a large scale change. Okay. I want to reorder the folders or something. Okay. But I want to not touch the main perhaps. So what I can do is git branch. So git, I can create a new branch. Okay. Git checkout minus B. I can give some branch name. So reorg folders. Okay, let's call it that. So what happened now is that now it's in like, okay, let's now talk about your feature, and whenever you make commits now, they're going to be in a different branch, and so your main or master branch here is not going to get affected. So now let's actually do the reorganization. So let's look at this. So we can do Flask examples. Kubernetes examples. Anything else? Okay, let's say I created 3 folders. Okay, I'm just going to reorganize just to show like, and then I can do git move so that it's tracked. The moving is tracked. Git move Flask example star. I mean, I'm just moving all these 5 folders to Flask examples. Okay. I mean, I'm just doing it in command line, but you can just select all of them and just put it in the folder. Okay. Okay, start to. Okay, those who have moved, and then the last one is Docker. I think there's a Docker something else. Okay, Docker example to Docker examples. And if you directly just move, then tracking is not properly captured. I believe it'll show something is deleted and something untracked, perhaps. Okay, so if you do, I don't want to do git status, but okay, let's do git status. You'll see a bunch of changes. Okay, lots of things got moved here and there, here and there. Okay, so git commit minus minus m. Actually, okay, so A means add and give a message. So remember last time I added explicit files and then this time this is just a reorg of everything. Let's just add everything to be committed and just make a commit message. Reorganized folders. Okay, so it says all these things have been clean. It's been done. So if you look at git status, now it says you're on that branch, nothing to commit, in the sense you made all the commit, everything is clean. I mean, everything is snapshotted. Okay, so if I do git push, we are not on the, this branch is like something we created locally. It's not there on the remote. So we could get an error, right? It says has no upstream branch. Okay, so it just says, okay, do it this way. So let's do it that. Okay, so we were able to create a branch, separate out, read some organization, and push it back. So now let's go back to our folder here, our repository. You can see that actually there are branches. I mean, I didn't notice this, but there are 4 branches. So it says reorg folder has folders has recent pushes in less than. This is just it's how it works. So actually, if you look at the branches, there are actually a couple of other branches, but reorg folders is the other branch. Okay, so actually, if you look at the master branch or the main branch here, it's exactly the same as before. Okay, it's only fixed. The only recent thing is that we improved the example. It has not affected anything. Now, what we can do is actually, as it shows prominently here, doesn't show all the time, but because we just did the push to the other branch, it shows. You can say compare and do a pull request. Okay, this is what that verb merge, and so we saw the verb branch, which is to separate out and do some work, and the only thing left is to merge it back. Okay, GitHub calls it pull request, as I said. Bitbucket calls it merge request. It's basically the operation of merging 2 different code bases. Okay, with merging, we are not going to get into complications of this because this is like very short, but merging can have complications. Okay, so if 2 people edit the same line and 2 different developers were working on the same line and changed it, then there will be a conflict of which version is actually the correct one to be merged. Okay, but let's stick to the happy path. So here we have reorganized something, and we want the master branch or main branch to reflect that. Okay, so the way to do it is you can do it. This pull request merging happens on GitHub side, as in the remote side. If you wanted to do merge on the locally, let's say you're not using GitHub, you're just tracking locally, because you don't need to use GitHub. You can actually do this snapshotting locally as well. You can use the merge command to do that there. Okay, I'll not show that because I think this is already consuming too much time. So I'll just do pull request. So let's go to pull request. Okay, tab, and it's actually hinting how to do a pull request, but let's actually do it the usual way if you don't see that extra hint. So new pull request, and it's saying, okay, what are the 2, what do you want to merge into what? Okay, so base is master, which is what I want to merge into the new changes, and I want to merge this branch called reorg folders. Okay, it need not be just reorg, right? It can be actually a feature development. So it's saying, okay, a lot of files were changed, 37 files were changed. There's only 1 commit in that side, and it's actually telling you what all probably happened. There was no code changes, it was just things which moved. And now you can say create a pull request. Okay, this is just GitHub specific details, so I don't want to spend too much time on it. And you can say reorganize folders. Examples of a specific were put into a folder. Okay. So generally, you want to create a pull request so that other people can actually read it, review it, and approve it, and therefore it goes into the main. Okay. So you can do many things, but let's just create a pull request here. Okay. So once you do that, if you go back to the repository again, you or other team members can go to the pull request and see, oh, there's somebody did some update on the code, and this is the one which is open. So you can go there, and if you are a reviewer, like generally, the person who created the pull request can add people as reviewers here. But if you are a reviewer, you can review it and add comments and so on, like all the social stuff that you can do. And if you're happy with it, and if you have the authority to merge the pull request, merge the pull request just means merging the changes into the reference branch, okay, main branch. So you can just say, and it also tells you if there are conflicts or no conflicts and so on. Okay, not let you do it, and then you can just say merge pull request. Okay. Okay, successfully merged and closed. Okay, so there was an open pull request, it was merged and closed. And now if you go back here, you should see in the master branch, it's not protected, but you should see Flask examples all in one folder, and other Kubernetes examples in one folder. So now those of you who did git clone with HTTPS or whatever, you can do git pull to get this this reorganization, and also the Docker example, if you wanted updated Docker example. You can get that by just typing git pull. Or if you are using GitHub Desktop, just clicking one of the buttons there. Know which one. Any questions here? No questions. Everybody's exhausted. Okay, so I'll stop here. So for the next rest of the class, you should try at least something, either the Docker side or the Git side. Or if you have projects, you should form teams. Let me know what you're picking up and so on. Okay. So I will turn this off so that it's not very glary, but I'll be around. So if you have any questions, didn't follow something, I'm here to help you. Okay.